Hi, everybody. Um, I opened up the uh, b- book that you don't have or doesn't exist in this class. But anyway, um, and then I noticed that that monster of a question I did first hour doesn't even exist in the homework here. So just something Mrs. Fasola had a nice idea for, but I think it ended up. This is probably more for next week. So ignore that happened first hour. I'm not even going to do this in the other hours. Probably I just so you know, now I just cut into my time that I said here. So I'm not doing that one. Um, we're going to go ahead and continue on with this one. And then probably in the other hours, I'll get some of these done. So you just move the movie until it's an example that wasn't covered in class. Okay, I got to go because I promised my first hour would be 10 minutes here. All right, remember, root it, reduce it, or rationalize it. Root it, well, nothing is a perfect fifth root, and then nothing reduces. So I must rationalize. So the first thing I got to figure out is I got a fifth root, and I got to think about that denominator, which that's the thing that can't happen. You can't have a radical in the denominator. What is 16? And ultimately, you can write them all out or understand that it's 2 to the fourth. Oh, so close. And then x to the third, that's what it is. It's xxx. So what do you need in a fifth root? You need something times itself 5 times. So how many more twos do you need? One, Mr. Samuelus. So multiply both top and bottom by the same thing because this equals 1, and I'm multiplying by a form of 1. A 2 underneath that fifth root to make this 2 to the fifth. And then say it, an x squared. I don't have time for this. All right. So you need to say these things to yourself. All right. So that's why I multiply both top and bottom by this. And then up in the top, 7 times 2 is 14. That is not a perfect cube or fifth root, fifth root, fifth root. And x squared doesn't come out of jail. But here, I'm going to write it. But when you get this figured out, this is a useless step. You now have 2 to the fifth, and you now have x to the fifth, and you've created a perfect fifth root on the bottom, both cases. So therefore, the silly thing about simplifying radicals, you no longer have a radical in the denominator. And as I said, you cannot cancel something that's in a radical when something's out of a radical. So 14 over 2 doesn't cancel, and x squared over x can't cancel. Stuck in jail, like you often feel in my class. Okay, and then real quick, write this down and pause it. These are rules for like radicals. Like radicals are just like terms. Look at it. 3x plus 4x is 7x. So 3 root 2 plus 4 root 2 is 7 root 2. All right. And then examples of like radicals. These would be like radicals, believe it or not. This is like a monster variable, and this is like a monster variable. So guess what? You have 1 and 4 of this monster variable. You have 5 of these monster variables. All right. It's just like 5xy plus 5xy plus 2xy. That's 7xy. When you have double variables in a term, well, if they're the same double variables, then they are. Not like radicals. When the indexes are not equal, you don't have like radicals. So the next set of terms is, okay, adding or subtracting radical expressions, and this one just doesn't happen to have variables in it. Oh, you're going to hate this, but what you got to do is simplify each one of these. Well, again, I told you I was going to do this fast. Square root of 4 is 2. 16 cube root is, you got to get that down to 8 and 2. I almost put a 3 there for some reason. Cube root of 8 is 2 cube root of 2. 250 is 125 times 2. This is, and I like circling the perfect squares or cubes when I break down these products. That is the, 5 times 5 is 25, times another 5 is 125, and then cube root of 2, and then minus root 5. And then lo and behold, you end up having like terms. 2 root 5 minus 1 root 5 is 1 root 5. And then negative 2 cube root of 2, I'm okay, plus 5 cube root of 2 is 3 cube root of 2. Those are like variables. Like that's like minus 2x plus 5x. That's 3x. Okay, got to move on. Not doing that one word problems. You can read and then figure out what's going on there. All right, let's do another one. Okay, boom shakalaka. I wonder what time we're on here. I have no time to check the time. All right. This is 1,000 times 2. Cube root of 1,000 is 10. These were the perfect cubes that I wrote down. And then plus, well, that's just root 2. Nothing going on there. And then cube root. What's a perfect cube root? Wait, 128 is 2 times 64. And that's perfect because the cube root of 64 is 4. Cube root of 2 stuck in jail. So the uncircleds are stuck. And then lo and behold, you got another set of like terms. 10 plus 4 is 14. Cube root of 2 plus root 2. All right. Okay. What do we got over here? You're gone. All right. Absolutely. I think we'll be pretty quick here. Okay, now multiplying, and then it might require some stuff that happened up there. Got a foil, good foilers, by the way. Okay, so our inclination should first be to distribute when I have radicals with one of them looking like a binomial. And then lucky for that, because the cube root of 49 doesn't simplify. 49 is 7 times 7. That's only 2 sevens. I need 3 7. Well, look at this. Okay, so this one becomes 2 cube root of 7. And now when I distribute this, this is the cube root of 7. Maybe I'll slow this down for you. And then the cube root of 49, which is 7 times 7. Oh, then look. Remember I told you liberally I'm going to use this rule. When it's a cube root times a cube root, you can write them all under 1 cube root. And then I don't have to find out what 7 times 7 times 7 is. That is 7 to the third. Cube root of 7 to the third is 7. And then these don't match because that's like 2x minus 7. You can't combine those as like terms. All right. Okay. You can stop the video. So I'm moving, man. I'm moving. You're gone. All right. And then good factors are good. Nice. And I hope you're saying that in Compass and everyone's like, what? Why is he talking to himself? Or she, or whatever. All right, 2x squared is that first one. And then this is negative 2x root 3. And this is another negative 2x root 3. Do the lines. And then negative times a negative is a positive. Root 3 times root 3 is root 9. All right, that's like liberally using that rule I just said. That would be root 3 times root 3, which is root 9. Ultimately, that is 3. And I would prefer that you write just 3. And then how do you write this? Descending order? What? I don't care. I couldn't care less. 4x, who goes first, second, or third? Probably the 4x squared first. And then just because of the order that you did this, the 3 at the end is fine. And then none of these are perfect, or none of these are like terms, is what I mean to say. So that's that. Let's see what other examples Mrs. Fasola had. That's just another foil, not needed. That's just another distribution. 6 has a 3 in it, so you'd end up with root 6 times root 3 is root 18. 18 is 9 times 2. Then you'd take out a 3 out of there. Square root of 9 is 3. Okay, now I got, don't look at this. I forgot to erase this. Don't look. Oh, that looks like a nightmare. All right, and this is maybe I'll do 2 of these, like, and then we'll end it at the day. Okay, this is nothing like the last one that I rationalized. Didn't I start with that? I'm already having short-term memory loss here. Oh, it's hectic. And I look old. God, look at my eyes. I need to do something about these bags. Anyway, it's not like this. Okay, there's a difference with the last one. This one, I just have a product on the bottom, and then I just have to figure out how do I get a fifth root. Sometimes itself 5 times. This one, I get dizzy with all these examples here. Okay, I know what some people will say. All right, I got a root 5 in there. So you know what? And it's just a square root, so I can just multiply top and bottom by root 5. Because the rule is I cannot have a radical in the denominator. problem with that is, everybody, is all you did was shift where the issue is. Because now you got a root there, and then sure that is. So that would equal root 5 over 2 root 5 plus 5. And then don't tell me the root 5's cancel. That's a 6 over 5 equals 2 error. Stop doing that. So all you've done is shifted where the radical is. You still have a radical in the denominator. You're gone. That is not what you're supposed to do. Okay, so I'm going to leave that up there as naughty math and then tell you what you have to do. And then this is going to come out of left field. But the only thing you can multiply that by in order to get rid of those radicals or that radical is by what's called the complex conjugate. Can everyone say complex conjugate? Okay. And I got to do it on top and bottom because then this is equal to 1. So this came out of my brain. I'm going to multiply top and bottom by this conjugate. And then the numerator is just a distribution. 1 times that is that. On the bottom, 2 times 2, I don't have enough room. Yeehaw. 2 times 2 is 4. Now, I'm going to do this, but I really shouldn't have to because what's going to happen to the middle term? Z. They're going to cancel is the answer. And then root 5 times negative 5. After my last example, everyone should know that that's negative 5 because root 5 times root 5 is root 25. Square root of 25 is 5. And then notice you're gone and you're gone. There is no longer a radical in the denominator. And as a Fattermact, everyone should understand that this looks much more simplified than the original question. And you no longer have a fraction. So multiplying by the conjugate, and I'll do one more of these of the 2 that Mrs. Fasola had down on the bottom. And I just didn't feel like doing these other ones. Well, that one's a monster. I think this one's just as monstrous. Okay, so we'll do it one more time. Remember, the key thing that I showed you before, you cannot have a radical in the denominator. Okay, so that's the problem. Number 2, you can't multiply both top and bottom by root 3. That just shifts the problem to the 2. So this is not the way to go. The way to go is to multiply by the complex conjugate of, or the radical conjugate is what I should say. Complex is not a word you know yet. Again, my cat class leaks into this class. We're talking about complex numbers in that class. But anyway, don't worry about that. So no, not just root 3. That doesn't work. All right, and then I'm not showing the middle term. The middle term is going to cancel. On the bottom, 2 times 2 is 4. Middle term, opposites. Negative root 3 times positive root 3 is minus 3. Well, that's nice. Okay, because that's going to end up being 1 on the bottom and then not much to do. Unfortunately, on the top, we got to go a full FOIL. 5 times 2 is 10. 5 root 3. I'm probably over 10 minutes. Couldn't care less. It's all about understanding. Negative 2 root 2. You got compass. You got 35 minutes. Well, I need to go compass another class. Well, then do it later. I don't know. Everyone's always complaining. Go to Twitter. Complain on there. I'll never look at it. Couldn't care less about Twitter. It's a garbage dump of thought. Anyway, sorry. Root 2 times root 3 is root 6, and it's negative, and nothing comes out of there. So, again, I told you I was liberally going to write, root 2 times root 3. I can put them underneath one root and then actually multiply them. So I said I was going to do that. And then lo and behold, well, this is nice. There isn't one like term up in the top. 4 minus 3 is 1. So anything over 1 is the thing. Well, this is really strange. That's the final answer. This is equivalent to that fraction up at the top. Wow. I don't think I did that one last year because I don't recall that happening. That's wild, weird, wacky stuff. Okay. Where are we at on time? Oh, I can't tell, I guess. Oh, well, until I'm stopped sharing. Have a good day and weekend.